So today is our lesson 3 from the radicals unit, and we are multiplying and dividing radicals. Alright, so just as a starter, some simplification from yesterday. If I wanted to simplify the square root of 20, you can do a little tree if you want, 2 and 10, 2 and 5, and right here I notice that my pair is 4. So I can write this as the square root of 4 multiplied by 5, which is equal to the square root of 4 multiplied by the square root of 5, which is just 2 root 5. So why this is important is that I can actually go from the square root of 4 multiplied by the square root of 5 backwards. Okay, so I can just take this if it's outside, like this. I can always go in the reverse and say, well, this is the square root of 4 times 5, which is just the square root of 20. And again, this is true because of the exponent laws. Okay, and so I've talked about the exponent laws a few times, and just as a squared times b squared is equal to a times b squared, we can say the square root of 2, which is the same thing as 2 to the half. Remember, we can write a square root as n to the half, or the square root of 2 is 2 to the 1/2, multiplied by the square root of 3. And using our exponent laws and our product or our power rule, we can rewrite this as 2 times 3, and we can do this because they have the same exponent. And we can just say that this is the same thing as 6 to the half, or the square root of 6. And so with this, all we're saying is that I can take this, the square root of 2 multiplied by the square root of 3, and because they're both square roots, I can do 2 multiplied by 3, which is just the square root of 6. Okay, so we don't have to write it all out like this with the exponents. We can just go right from here to here in one step. So the question is simplify the following and write as a mixed radical. Alright, well, our goal to start off with is to write it as an entire radical and then simplify. You might see some shortcuts as you go, and if you do, that's great. It might help to write it as the square root of 10 multiplied by the square root of 15, which I can write as the square root of 150. Now, I want to write it as a mixed radical, so 150 I can write as it's divisible by 2, which is equal to 75, and that's divisible by 5, and that would be 15 times, and I can write this as 5 and 3. Because it's a square root, I'm looking for pairs. I have a pair of 5s there, so I can write this as the square root of 25 multiplied by my leftovers. Well, my leftovers are 2 and 3, so times 6, which is the same thing as the square root of 25 multiplied by the square root of 6, which is just equal to 5 root 6. And now I have a mixed radical. Okay, so we're going to get more complicated. Now I have 2 multiplied by the square root of 6. If it helps you, rewrite it like this. 2 multiplied by the square root of 6 multiplied by 3 multiplied by the square root of 8. We'll put a little multiplication symbol in there. Now, order of multiplication does not matter. Just as 2 times 3 times 5 is equal to 30, 5 times 3 times 2 is also equal to 30. Okay, so I can reorganize this and say, well, 2 multiplied by 3 multiplied by 6 multiplied by the square root of 8. So this is just 6 root 6 times root 8, and I can rewrite this as 6 and 6 multiplied by 8, which is 6 root 48. You might have wanted to do some extra steps or some less steps in there. That's okay if you wanted to. And then I'm going to factor this because I want to write it as a mixed radical. So 48 is 2 and 24, 2 and 12, 2 and 6, 2 and 3. It's a square root, so I'm looking for pairs. I've got a pair here and a pair here, and I have some leftovers. So I can write this as 6 multiplied by the square root of 4 multiplied by 4 multiplied by 3. I'm going to break it up. I've got the square root of 6 multiplied by the square root of, 6 multiplied by the square root of 4, multiplied by the square root of 4, multiplied by the square root of 3, which is just 6 multiplied by 2, multiplied by 2, multiplied by the square root of 3, which is just 24 multiplied by the square root of 3. And here is my simplified mixed radical. Okay, let's do another one. So I have 3 multiplied by the square root of 2b multiplied by 5 multiplied by the square root of 12b. Again, order of multiplication doesn't matter. So I can rewrite this as 3 multiplied by 5 multiplied by the square root of 2b multiplied by the square root of 12b. Alright, I'm going to do a few steps at once. So we know that 3 multiplied by 5 is 15. And I can bring these into one entire radical, 2b multiplied by 12b. Alright, so this is the same thing as 15 multiplied by 24b squared. Alright, well let's look at the square root of 24. So 24 can be broken down to 2 and 12, 2 and 6, 2 and 3. And remember that it's a square root, so I'm looking for pairs. So I have a pair of 2's here. These are going to be my leftovers. So I can rewrite this as 15 multiplied by the square root of 4 multiplied by 6 multiplied by b squared. And now I'm going to do 15 multiplied by the square root of 4 multiplied by the square root of 6 multiplied by the square root of b squared. Alright, square root of 4 is just 2. I can't simplify the square root of 6. Now, what about the square root of b squared? Well, b squared is just b times b. So I have a pair here. Remember, b is just a number. Okay, so I can just write this as the square root of b squared is b. Okay, now remember, order doesn't matter. So I'm left with 15 multiplied by b multiplied by root 6. And that is my answer. So now we have binomials multiplied by each other. Okay, so in this case, we're going to have to use FOIL. So I'm going to have my first, which is 3 multiplied by 1. And I have my outside, 3 multiplied by the negative square root of 3. I have my inside, root 3 multiplied by 1. And I have my last, which is root 3 multiplied by negative root 3. Now, if you're not sure, let's just write this out. Okay, let's just start by looking at what this means. Okay, so I'm going to do it over here. So I've got root 3 multiplied by negative root 3. Okay, so I have a negative multiplied by a positive. So I have negative root 3 multiplied by root 3. Leave my negative there. I can write this as 3 multiplied by 3, which is just equal to negative root 9, which is just equal to negative 3. So I'm going to rewrite this. I've got 3 minus 3 root 3 plus root 3 minus 3. Okay, well, easy stuff. I have a minus 3 and I have a positive 3. Those are like terms, so they become 0. Now I'm left with negative 3 root 3 plus root 3. Alright, roots are just the same as variables. Okay, so the nice thing with this is that I have minus 3 root 3's here, and I have a plus 1 root 3 here. So just as if I had minus 3x plus 1x, I would say I've got minus 2x's. Well, it's just the same case here, where we get minus 2 root 3. Alright, we're going to do 2 more. Next one. We have 2 divided by root 2. Now, one thing about fractions is that we don't like leaving negatives in the denominator. Okay? We also don't like leaving roots in the denominator. So what we noticed up here is that when we multiply a root by itself, we end up with an integer. So in this case, to get rid of, so our goal is to get rid of a root in the denominator. So with the information that we've looked at up here, where root 3 multiplied by root 3 became an integer, we're going to use the same idea. So when we have a root in the bottom, we're just going to multiply it by whatever root's there. So the top, super nice, I can't do anything. Okay? The bottom though, okay, remember we've got root 2 multiplied by root 2, which is the same thing as root 2 times 2, which is the same thing as root 4, which is equal to 2. And now, to simplify further, we always like to leave our fractions in the most simplified form. Notice that I have 2 divided by 2, which is just equal to 1. So my answer is root 2. And that's my solution. Alright, number 6 we can do 2 ways. Okay, so let's look at doing it the same way that we just did. Now, to start with, notice that my denominator has a root in it. So all I'm going to do is multiply by the root. So I'm going to multiply the top and the bottom by root 12, just as we do with common denominators. We would multiply the top by whatever we multiply the bottom by. So I end up with 5 root 6 multiplied by root 12 over 2 root 12 times root 12. Okay. The top, I can rewrite this as the square root of 6 times 12. The bottom, I have 2, and this is going to simplify to, you should all be saying 12. Well, that was super nice. And then I have 5 root, and 6 times 12, I believe, is 72. And on the bottom, I have 24. Now, I want to simplify this, okay? So I have 72, and if I divide that by 2, then I get 36, 2, and 18, 2, and 9, 3, and 3. So remember, it's a square root, so I'm looking for pairs. There are my pairs. I can write this as 5 root 4 times 9 times my leftover, which is 2, over 24, which is just the same thing as 5 times root 4 multiplied by root 9 multiplied by root 2 over 24. Getting closer. 5 multiplied by the square root of 4 is 2, multiplied by the square root of 9 is 3, multiplied by root 2 over 24. And now I can simplify because 24 is divisible by 12, 24 is divisible by 2 12 times. 12 is divisible by 3 4 times. So I end up with 5 root 2 over 4, and that is my answer. There is one other method that you could use here, and it is, again, we're always using exponent laws here. So 5 root 6 over 2 root 12. I could write this as 5 over 2 multiplied by root 6 over root 12. The reason why this is nice is because these are both square roots. So I can use my exponent power rule and say this is the same thing as this. Okay, now remember, it's just 6 to the half over 12 to the half. And you saw in the power rules I could rewrite this as 6 over 12 to the half. And why this is super nice is because the 6 and the 12 simplify. We get a 1 here, and I get a 6 on the 2 on the bottom. Okay, so then I can rewrite this as 5 over 2 multiplied by 1 over root 2. Again, I'm using those exponent rules. We did have this originally, but the square root of 1 is just 1, so we don't need that. And then I can multiply the top and the bottom by root 2. Now, if you don't like this way, it's okay. You don't have to use it. We're doing multiplication of fractions, so we multiply across the top, and I get 5 root 2. We have multiplication of fractions, so I multiply the bottoms. Now, root 2 multiplied by root 2, you should be saying, well, that's just equal to 2. And so my bottom piece is just 2 multiplied by 2, which is 4. It's a little bit quicker, okay? Obviously, it's a lot less work. But if you're not sure, maybe watch it again. Try it. It's actually easier. It just seems a little bit more confusing. We really are using the essence of exponent laws here to make this transition from this to this. And just make sure that you're using those rules correctly if you're going to do this method versus the other one. I'm not going to do example 7. We'll do it in class on another day.